The objective of our experiment is to measure the total water hardness of a sample taken from a residential well in Florida. This hardness is expressed as milligrams of calcium carbonate equivalent per liter, determined through an acid titration. As we add hydrochloric acid solution drop by drop while continuously monitoring the pH with an electrode, we can clearly identify the second equivalence point. That point marks the complete neutralization of the bicarbonate ions that are paired with calcium cations. The Floridan Aquifer is a massive underground limestone formation that underlies most of Florida and supplies drinking water to millions of residents. As rainwater seeps downward through the soil, it absorbs carbon dioxide from the air and decaying plants. This carbon dioxide combines with water to form a weak acid that slowly dissolves the limestone. The overall process can be described simply as limestone plus water plus carbon dioxide produces dissolved calcium ions and bicarbonate ions. This natural process creates hard water, typically ranging from 150 to 180 milligrams per liter as calcium carbonate equivalent, though in some areas it can reach up to 400 milligrams per liter. Water from this aquifer usually has a pH around 7, which matched what we observed in our sample. In our titration, we added 0.02 molar hydrochloric acid in small increments to a 100 milliliter water sample while recording the full pH curve. The feature we focused on was the sharp, well-defined second equivalence point. At that point, all bicarbonate ions accept an extra proton and convert fully into carbonic acid, which occurs around pH 4.3. Carbonic acid then rapidly breaks down into water and carbon dioxide gas that bubbles out of solution. The total amount of hydrochloric acid needed to reach that second equivalence point directly tells us the total hardness of the water. The moles of hydrogen ions added from the acid relate in a 2-to-1 ratio to the equivalent amount of calcium carbonate. For our specific experimental setup, 100 milliliters of sample and 0.02 molar hydrochloric acid, the calculation simplifies easily. The hardness in milligrams per liter as calcium carbonate is approximately equal to the volume of hydrochloric acid liters multiplied by 10.
So in the previous transition, it showed how we recorded our data based off of every milliliter that we added to the water of HCl. We recorded its pH change, and we did various drops of 1 milliliter or 0.5 milliliters. After that data was collected, we made a graph showing the equivalence point. Right here is where it's the 15 to 18. So within this range of 150 to 180 is where the well water fell. This showing that it is a very hard water quality.
So within that 15 to 18 range is our second equivalence point. This shows where that HCl completely dissolved the calcium carbonate, driving off carbon dioxide gas.